Just we were discussing about method overloading yesterday. Okay, what method overloading is? As long as the method signature is changing. Okay, as long as the method signature is changing. The method signature in the sense number of arguments, data type of the arguments, and order of the arguments. Okay, as long as the method signature is changing, we can keep n number of methods with the same name in the same class is called as method overloading. Now, if the interviewer asks you like, can I overload static methods? Can I overload static methods? Yes or no? Yes, definitely. That's what we have done. Like these two are static methods, and this is overloading. Okay, we can overload static methods. Okay, can you overload non-static methods? Can you overload non-static methods? Yes or no? Yes. Okay. Method overloading doesn't consider whether it is static or non-static. The method overloading considers just the method name and the list of arguments. But static is the access modifier. The method overloading never considers the access modifier. Just it considers the name of the method and the list of the argument. The method overloading doesn't consider even the return type of the method. Okay? So while checking duplicates, method return type will not be considered. Only the method name and the list of arguments will be considered. Okay? And even static as well as non-static methods can be overloaded. And some people in the industry, it's not official as per the Sun Microsystems. Some people in the industry call method overloading as static polymorphism. Okay? If the interviewers explicitly ask you what is static polymorphism, then only tell about method overloading. Okay? Otherwise, skip the term static polymorphism. As per my base knowledge, there is no concept of static polymorphism, but some of the guys in the industry will call this method overloading as static polymorphism. But if the interviewer asks you what is static polymorphism or what is the difference between static polymorphism and dynamic polymorphism, then tell about method overloading. If the interviewer explicitly asks you static polymorphism, then the static polymorphism is nothing but method overloading. Okay? But as per my knowledge, there is no concept of static polymorphism. But even for me, many of the guys have asked interviews what is static polymorphism. I should not argue with them that there is no static polymorphism. Rather than arguing with them, just tell about method overloading. Okay? Static polymorphism and method overloading are one and the same. What is the exact and actual polymorphism that we discuss later on? That's the? ఇది నువ్వు నిన్న ప్రాక్టీస్ చేసావా? ఓకే, సేమ్ దాన్నే మార్చావు. ఓకే, నో ఇష్యూస్, ప్రాబ్లం లేదు. Now, which method is executed? Which method is executed? The first or second? Okay, it will give a compile time error just because whatever the content that we are stringing, it is in double quotes. If it is in double quotes, it will be a string. Okay? Whatever the content might be, it might be integer content or any content. If it is in double quotes, it will be a string. So those two methods are not compatible. So it will give a compile time error. It will give you a compile time error just because we are sending 10 in double quotes. In double quotes, whatever the content it might be, it is considered as string. Okay? So this calculate interest with check string is not there. So it will give a compile time error. Gitu, gitu. Sorry. This it is giving, it's not able to find symbol calculate interest which takes a string. And a method can have a number of arguments. A method can have any number of arguments. It's not like a method should have a single or two number of arguments. A method can have any number of arguments. Okay? Now, which method is executed? Error. Why it will give error? Since it goes to the second method, we are trying to assign the value now. Which one will go, first method or second method? Second method. Okay, if I execute class, okay, just it is going for the second method. Okay, and I will remove this not required. Now can I call this as method overloading? Yes or no? Yes. Now, which method will be executed? First method or second method? Definitely the first method will be executed, just because okay, I am sending 0, send out 0, integer and a double, so definitely first method will be executed. So the first method is being executed. Now, is there any method which has the exact match? No. Okay. Is there any method which has at least one argument as exact match? Is there any method which has at least one argument as an exact match? Yes. Which is the method? First method. So it will prefer the first method. It has at least one argument as an exact match. So it will prefer the first method. Okay. So definitely the first method will be executed. Now, no? Which method is executed? First one or second one? Definitely the second will be executed. Which one is this calling? The second one. Just because, see, the first argument 0 is the integer. Now, is a exact match integer found? No. Let's consider the second. The second one is integer. Is the exact match integer found? Yes or no? Yes. Exact match integer found. Then it will come to left and it will search. Can double accommodate 0? Can double accommodate 0? Yes or no? Yes. So it will go to the second method. Now, which method it will go? First or second? First method or second method? First one. Okay, it's calling the first one. Just because first it will try to find the exact match. The exact match is not found. Okay, then it will go to the higher level. So higher to int is log. Will it go to the first method or will it go to the first or second? Second? Second. What's the reason that you are telling second? First match. Okay. But it will not search for any first match or second match. It will search for the exact match, whether it is first or second. Okay, the exact match will be given the same preference if it is the first argument or second argument. See, it will not give any preference to the first argument, or it will not give less preference to the second argument. It will give the same preference, okay, to the match, either it is the first or second argument. Okay. Now, if I compile this, okay, it will give a compile time error, just because both the method calls for this method call, these two methods are individually compiled successfully. These two methods individually they are compiled very successfully. But while calling the method, what I am doing is I am calling with some generic values. So the compiler could not able to decide to which method the method call should be linked. Both are having the same preference. See, if I consider the first argument, okay, if I consider the first argument, then the second method should be preferred. If I consider the second argument, the first method should be preferred. So the compiler could not able to decide to which method it should link for the method call, just because both have the same preference. These two methods individually they are compiled successful, but this method call is a compile time error, just because the compiler could not able to decide to which method it should link. Okay, both are equally valid. Both are equally preferred. If both are equally preferred, then the compiler could not able to decide to which method the compiler need to make a link, to which method this calling statement should be linked. Okay, and this situation is called as ambiguous situation, and this method call is called as an ambiguous method call. Okay, this method call is called as ambiguous method call. This method call is called as ambiguous method call. So there is ambiguity. There is ambiguity, okay, whether the first method should be linked or the second method should be linked, just because both are not exactly matching and both have the same preference. If I consider the first parameter, then it should go to the second method. If I consider the second parameter, it should go to the first method. So both are equally matching, and the compiler really could not able to decide to which method it should link, to the first method or second method. Okay, and these two methods individually are compiled successful just because they are overloaded. But while calling the method, we should take enough care that we are not calling the methods ambiguously. It's our responsibility. Okay, while calling the method, we should be enough careful that we are not calling the methods ambiguously. While calling the methods, okay, we should call using exact data types. While calling the methods, at most we should try to make use of exact data types. Okay, we should not call the methods ambiguously. While calling the methods, we should take care that we are calling the methods by making use of exact data types. Sorry, exact values. To avoid the ambiguities, just we should call the methods using exact values. Now, will there be any ambiguity? Will there be any ambiguity? No, just because we are first what we are doing is we are calling 0 10.0. So definitely it will go to the second method. Exactly, it is int and double. Okay, there is no ambiguity. But if we give both int and int, there is an ambiguous situation. It is an ambiguous situation. Okay, we should avoid ambiguous method call. Let's consider like I am not calling the method. Now will it give a compile time errors? Let's consider like, just let me show you the compile time error. Now if I call like this, definitely it will be a compile time error, right? Okay, just if I compile this, reference to calculate interest is ambiguous. Both calculate interest double int and calculate interest in double, okay, have the same preference. Both are matching. So It will give a comparison error. Now let's consider that I am commenting this method. If I comment this method, will there be any comparison error? No. The method declarations and definitions are not comparison errors, but the way that we are calling a method is ambiguous. So we should avoid ambiguous method calls just by providing the values of exact data types. Okay? Understood? This is how we need to do. And this is what method overloading is. Okay? This will complete method overloading. Which method will be executed? First or second? Will it give 1, 2 or both? Just see the example. Just see the modifications that we have done. 1, 2. That's why I asked, try to revise the previous classes also. It's a comparison error just because I am making a call to the calculation interest method in the 17th line. In the line where the cursor is there, what I am doing? I am making a call to the calculation interest method. Calculation interest method by passing t and p. What is t? What is the derivative of p? Double. So p is integer. Double and integer. I am calling calculation interest which takes double and integer. Is there a calculation interest method which takes double and integer? Yes. Where it will go? Here. But it's a static method and this is a non-static method. So it will give a comparison. Okay? Just that's why I asked, practice the current examples as well as consider even the previous examples also. Okay, then only at the end of the day you can remember all the things. This will be a compulsion error just because we are calling calculation interest method which is non-static inside a static method. It's not even main method. Any static method is the same. No? Now will it give an error? just we are calling calculate interest, which is taking double an int from the main, which is static. So now also it is a compile time error. Okay. See, we are calling calculate interest, which is taking double integer. Now which one will be linked, the first or second? First. But we are calling calculate interest, which is static, sorry, which is non-static inside static method when. Okay, so it will be a compile time error. Now let's consider that it's commented. Now will it give a compile time error? Just see this statement and tell whether it is a compile time error or not. Yes or no? Will it be a compile time error? Why it is a compile time error? P? I could not able to get it exactly. You are telling something like it is a compile time error. Could you please tell why it is a compile time error? P and D? Null? I could not able to exactly get it. Could you please tell it loud? No value. See, that's what I told. The compiler will not check whether the value is there in that or not. The compiler will check only the possibilities. That's what I told in the previous example. Okay? Will it give a compile time error? Yes or no? Why it will give a compile time error? Non-static? Two static method. See, in the first example itself I told like using non-static inside static is a compile time error. But using static inside non-static is not a compile time error. This will never give you a compile time error. Okay? Using non-static inside static, yes, it is a compile time error. But using static inside non-static will never be a compile time error. Static can be used anywhere without an error. Okay? What I am doing? I am calling the static method from the non-static method. I am calling static method from non-static method, which will definitely compile. But if I call in reverse manner like this, if I call in reverse manner like this, now it is a compile time error. Just because I am calling calculate interest by sending double an integer. The calculate interest which takes double an integer is a non-static, and non-static is being used directly in static, which is a compile time error. But now it is not a compile time error. Just because I am using static inside non-static, but this is allowed. Static inside non-static. Static can go anywhere without any issue, but non-static cannot be directly used in static. But non-static can be directly used in static. Sorry, non-static can be directly used in non-static. There is no issue. Non-static can be used in non-static. This is correct. Non-static, static can be used in non-static. This is correct. Static can be used directly in static. This is correct. But if I use non-static inside static, then it is a compile time error. This is the only thing which is not allowed. Okay? Non-static inside static is not allowed. That's the only thing not allowed. The remaining three things are allowed. Non-static can be used directly in non-static, static can be used directly in non-static, and static can be used directly in static, but non-static is not allowed directly in static. This is the only compile time error. Don't combine the compilation and execution. Execution is different than compilation is different. First, compile the individual units, individual methods. After individual methods are successfully compiled, then only go for execution. Okay? And right now we could not able to call non-static methods. Okay? From a static members. Okay, in the same way, let's consider that we have now will it be compiled successful? Will it be compiled successful? Yes or no? Definitely yes, just because we are calling calculate interest which takes it's not we are calling calculate interest which takes okay double and integer, so it will go to the this, and this is non-static as well as this is non-static. Okay, let's consider like now I am calling this from main. Now will it give a compile time error? Now will it give a compile time error? Yes, just because this is a non-static method. That means I cannot make use of non-static method inside the static method even though it is the same class. That is one thing. And another thing is, let's consider like I have another class where I have a test method. Okay, let me consider that I have system.out.println. The another class and member demo class, are they in the same class or the same .java file or different .java file? Same .java file. Okay, both another class as well as member demo class are there in the same .java file. Now I am trying to call test method. Okay, I am trying to call the test method which is in the same .java file. Which is in the same .java file. Now, what is the error it is giving? Cannot find symbol method test. That means it could not able to recognize the test method. It could not able to recognize the test method even the test method is there in a class which is there in the same .java file. The class another is there in the same .java file. Even another is there in the same .java file. It could not able to recognize the test method. Okay, that means if you want to make use of a non-static method in a static method within the same class. Understood? The first thing is, if you want to make use of non-static method within a static method in the same class, could we be able to call directly? Okay, if you want to call non-static method from a static method within the same class, can we call like that? Can we call it like that directly? Can we call a non-static method from a static method within the same class? No. Okay, we cannot make a call to a non-static method from a static method within the same class. Understood? Can we call a non-static method of one class in a non-static method of another class? Can we call a non-static method of one class in a non-static method of another class? No. We were not calling. Okay, if you try to call, it was a compile time error. It's the same thing like in another class we had test method. Test method was non-static, and we were calling this test from calculate interest which is there in member demo. We could not able to call a non-static method of one class from a non-static method of another class. To do these things, we should require an object. Okay, to make use of a non-static attribute or a non-static method within the static executable blocks of the same class. To make use of non-static attributes or non-static methods within the static executable blocks of the same class. Just if you want, you can write it down. If you want to make use of non-static attributes or non-static methods within, okay, otherwise, yes. If you want to make use of non-static attributes or non-static methods, okay, in the static executable blocks, in the static executable blocks of the same class. You want to make use of non-static attributes or non-static methods in the static executable blocks. If you want to make use of non-static attributes or non-static methods in the static executable blocks of the same class, of the same class. That means, if you want, let's consider like, if I have calculate interest which is non-static. Now, if you want to make use of calculate interest which is non-static inside main which is static. That means, if you want to make use of non-static attributes or non-static methods, okay, in the static executable blocks of the same class, or if you want to make use of non-static methods of one class, if you want to make use of non-static methods of one class in another class, or just make it like just erase it that non-static, rather than giving non-static methods, give non-static members. Just while defining, we done like if you want to make use of non-static methods of one class, okay, in place of non-static methods there, just keep non-static members. Okay, if you want to make use of non-static members of one class in another class, then definitely we should create an object. In these two cases, if you want to make use of non-static members in static executable blocks of the same class, if you want to make use of non-static members in static executable blocks of the same class, or if you want to make use of non-static members of one class in another class, definitely we should create an object. Okay? Now, we shall see how we create an object and what happens when we create an object. Okay, before discussing what the object will do, let us see how the flow of execution will be here. Let's see how the flow of execution will be here. Okay, whenever the user executes Java space some command, space some class name, like this consider like member demo. Java space some class name. Then what the first thing you do is the runtime environment, the JVM what it will do means it will try to fetch a .class file with this name in that location. Let's consider like we are executing some location. Okay, so first the JVM will try to fetch the .class file. Okay, in that specific location. If the .class file is found, then the next step is the JVM will search for a main method, a valid main method in that location. Okay, JVM will search for a valid main method in this location. Okay, if a valid main method is found, then what it will means the JVM will initiate the process of execution. The JVM is initiating the process of execution means first it will load this class into the memory. The first thing is it will load the class into the memory. Okay, if the main method is found in that specific .class file, then what the JVM will do means it will load the class with the memory. It loads the class with the memory means it divides the members into specific areas of storage. Okay. Basically, the members will be stored in different areas. Like, let's select in memory that the JVM assigns. We have two regions. One is stack, second is queue. Now, I think in C, all the functions will be stored in stack. Am I right? Yes or no? Yes. But in Java, nothing will be stored in stack. Everything, all the storage related stuff will be there in the heap only. Okay? All the storage related stuff will be there in the heap only. Heap is a permanent storage area in Java. Heap is a permanent storage area in Java. And stack is a temporary execution area. Stack is a temporary execution area and heap is a permanent storage area. So, whatever the storage related stuff, attributes or methods or constructors or initializing blocks or the class related information or whatever it might be, everything will be stored in the heap itself. Okay? Everything will be stored in the heap itself. Now, in the heap, the things will be stored in a specific area. Okay? Now, for each and every class, there will be a class area. For each and every class, there will be a class area. Okay? In the class area, all static attributes and static methods are stored. For each and every class, there will be a class area where all the static attributes and static methods are stored. For each and every class, there will be a class area in the heap where all the static attributes and static methods are stored. And the non-static methods are stored in an area named method area. Okay? The non-static methods are stored in a method area. Non-static methods are stored in a method area. And the non-static attributes are stored in the object. Non-static attributes are stored in the object, and even the object will be there in the heap. Even the object will be there in the heap. Non-static attributes are stored in the object, and even the object will be there in the heap. The object contains two things. One is it will have its own set of, okay? It will have a unique set of non-static attributes. Okay? Let's consider like if I create 10 objects. Okay? Let's consider the class has two non-static attributes I and j. Okay? So the class will have its own set of non-static attributes. I, j. Each and every object will have its own set of non-static attributes, and each and every object will have a reference to non-static methods. Let's consider like this is the test method we have, which is a non-static method. Then each and every object will have a reference to the non-static method. each and every object of the class will have a reference to all the non-static methods of the class. Let's consider like we have two methods, test 1 and test 2. So each and every object there will be a reference to the non-static methods. For all the non-static methods, there will be a reference from the object. For all non-static methods, there will be a reference from the object. And we cannot access the method area from the class area directly. We cannot access the method area from the class area directly. If you want to access the methods in the method area, then from the class area we should access the object, and from the object we have a reference of non-static method. So through the object itself, we can call the non-static methods from the class area. That is non-static methods from the static methods. If we want to make use of non-static methods from the static methods, then we should take the object, and through the object only we can make use of non-static methods. Okay? Just because each and every object will have a reference, to all the non-static methods. Every object will have a reference to all the non-static methods. Okay? And let's consider if I have two non-static methods, then there will be two references. Okay? Reference 1 and reference 2. The reference 1 will be referring to the first method, and reference 2 will be referring to the second method. It's not, I'm telling it in a logical way. It's not the exact name reference 1 and reference 2. Just it is a logical concept. Okay? And each and every object will have a reference to all the non-static methods. So, if you want to make use of non-static methods from static methods, or let's consider like I have another method area. Which has calculate average. This is the method area of member demo. Now, if I want to make use of this method from this method area, see, this is also method area and this is also method area. Now, calculate, sorry, it is calculate interest, right? Now, in which class calculate interest is there? In which class calculate interest is there? Member demo. Now, is the method area same for calculate interest and the test method? Is the method area same for calculate interest and test method? Will it be the same or different? Definitely different. I don't like each and every class has its own class area and its own method area. Okay? So, the method area is different. So, what we will do? If you want to make use of this method area and this method area, what we need to do? We should come to the object only. So, if you want to make use of non-static methods in the static executable blocks, or if you want to make use of non-static methods, or if you want to make use of non-static members of one class in another class, definitely we should create an object. Understood why we should create an object? Just because the storage areas will be different. Okay? Since the storage areas are different, okay, so we should create an object to make use of them. Okay? Definitely, if you want to access the non-static methods inside the static executable blocks, or non-static methods or attributes of one class in another class, definitely we should create an object. Understood? And the object will be stored in a tree. And for a class, I can create any number of objects. For a class, we can create any number of objects. There is no rule for the number of objects that we are creating. For a class, we can create any number of objects. But it should not increase the heap size. Okay, it should not cross the heap size. The number of objects that we are creating should not cross the heap size. Just because by default some 512 MB will be heap size allocated by the JVM. By default, the JVM will allocate 512 MB as a heap size. Okay, and just we have options. I'll discuss about options later on, but even we can increase this heap size also. Okay? That means up to 512 MB we can create objects. But if we cross that limit, then it will give an error. Okay? We should create the objects only up to this limit. Up to this limit. If you cross this limit, then it will give a runtime error. Okay? Now, how we can increase the heap size that we will discuss later. But remember that by default it will create 512 MB as a heap size. Okay? And we can increase or we can decrease the heap size. If not required, we can even decrease the heap size or we can even increase the heap size. How we can increase or decrease, how we can alter the heap size, we will discuss later on. But by default it will allocate some heap size. If we create objects or if we have some members which will make the heap size to increase, then it will give a runtime error. If you have members or we have some entities which make the heap size to increase, okay, or which crosses the heap size, then it will be a runtime error. Okay, if we have the memory in the heap, if we have the memory allocations in the heap which cross the heap size, then it will be a runtime error. We'll discuss how and when the runtime error occurs. But all the storage related stuff will be there in the heap. Let's consider that this calculate interest is static. Let's consider that this calculate interest is static. And we are making a call from here. Now will it be compiled? Yes or no? Calculate interest where I am sending double that int. Yes or no? Yes. So once the class is loaded into the memory, then all the allocations will be done. The class area will be created as well as the method area will be created. Now where the main method is stored? In the class area or the method area? That is the class area. The first calculate interest? The first calculate interest method? Class area or method area? The second calculate interest method? It will be in the method area. So, the first two methods are there in the class area itself. The class area of which class? The class area of memo demo class. Even another class will have another class area. Okay, so each and every class will have its own class area. So now the member demo class will have its own class area where we have two methods. Okay, main method and calculate interest. So now I am calling calculate interest from the main. So once the Java command is executed, what it will do? It will verify whether the .class file is there or not. It will verify whether the main method is there in the .class file or not. The main method is found and it will initiate the process of execution. In the process of execution, the first step is loading all the members into the memory. Okay, loading the class into the memory. Loading the class into the memory is nothing but allocating the memory to each and every specific member of a class. Okay, once the memory is allocated for the members of a class, then what the runtime environment will do means the runtime environment, okay, will start the execution from the main method. Okay, and in order to perform the execution, the reference of the method will be brought to the stack. The reference of the main method. The reference of the main method, the whole main method will not be brought to the stack. The whole main method code will not be brought to the stack. Only just reference to the main method will be brought to the stack. Okay, and the main method execution will be done. The execution part will be done in the stack. Okay? The execution part will be done in the stack. Okay? Once all the memory allocations are done, then the next step the JVM will do is it will bring the reference of the main method to the stack and it will start executing the main method. You bring the reference of the main method to the stack and it will start executing the main method. Now, if it starts executing the main method, what is the first statement in the main method? What is the first statement in the main method? System dot out dot println. Okay? Even println is a method. Even println is a method. Now, is the println available in this class? Is println available in this class? Did they define println or did they declare the println in this class? No. From where will you get? From where will you get the println method? You will get the library. Okay? You will get the println method from the library. Okay? So, now, let's consider like the first statement here is this I am writing SOP. SOP means system dot out dot println. The first statement is system dot out dot println of something. Now, for this statement, what happens? The println method is executed. Since the println method is executed, okay, the reference of println will be brought into the stack from the library. The reference of the println method will be brought into the stack from the library. And the JVM will make all the library engine stuff available. Okay? Now the println is executed. What is the purpose of the println? To bring some content to the console. So, whatever the purpose of content, just the method will be executed, and once the content is printed to the console, then the reference of the method will be removed from that. And the control will go to the end of the statement. Then the control will go to end of the fifth statement. Now, again after ending the fifth statement, where it will go? After ending the fifth line, where it will go? Sixth line. Okay, the sixth line, what I am doing? I am calling the calculating testament. Now, the control will come to the calculating testament. So, the reference of the calculating test method will be brought to the stack. The reference of the calculating test method will be brought to the stack. Now, inside the calculating test, am I calling any method? Inside calculating test, am I calling any method? Println method. So, the reference of println will be brought to the stack, and now let's consider the println is printing 1 to the console. After printing 1 to the console, what happens? The println method reference will be removed from the stack. Again, after executing this statement, where it will come? It will come here, and it will be done from here to the current place. Once the return statement is executed, then even this method will be removed. The reference of this method will be removed from the stack. Once the return statement is executed, the reference of this method will be removed from the stack by the JVM. Okay, so since I am executing the return statement, the reference of this calculating test method will be removed from the stack, and the control will go to the calling test. From where I am calling this calculating test method? From the sixth statement. So it will reach the end of the sixth statement, and again it comes to the seventh statement. In seventh statement, am I calling any method? In seventh statement, am I calling any method? Yes. What is the method? Println. So again, the reference of the println will be brought. Okay. And once the purpose of the println is over, then the println will be removed from the stack. Now, once the seventh statement is over, now is that the end of the main method? Is that the end of the main method? Yes. The end of the main method is reached, and here the reference of the main method will be removed from the stack. Understood how the process of execution will be? Nothing will be stored in the stack. Wherever and whenever it is required, the reference of that particular executable block will be brought to the stack. Okay? And the storage things will be done only in the heap. Understood? Everybody? Now, if we have understood this memorization and how the execution will be done, then only we will switch to the object concept. Now, all of you have understood when and where the memory is allocated and how the execution will be done at the runtime? Everybody? Now, we'll see how we can create an object and why the object will be useful. Okay? All of you got that? How the method executions will be done? The methods will not be stored in the stack. The methods will be permanently stored in the heap. Okay? And whenever it is required, the reference of the method will be brought to the stack. That's it. Okay? Understood? Now, if you want to make use of calculate interest, which is 10.10.0, now can I use this? Yes or no? Can I use this like this? No, just because it is a non-static method which is directly referred from a static method. But we cannot refer the method area from the class area, even if it is the same class. We cannot refer non-static methods from the static methods directly. Okay? If you want to make use of non-static members from static members, then we should create an object. Then how we can create an object means a keyword new space the class name followed by parenthesis. This will create an object. New space class name followed by parenthesis. This syntax will create an object for any class. Okay? Then the delimiter between the object and the member is dot. The delimiter between the object and the member is, or we cannot call it as delimiter, the connector. The connector between the object and its members is dot. The connector between the object and its members is dot. So this is the object created and we are connecting calculate interest to this object. Just how we can create an object means new followed by class name followed by parenthesis. This will create an object. Okay, this will create an object. And the connector between the object and its members is dot. The connector between the object and its members is dot. Now, if we try to compile and execute this, this will be compiled as well as executed successfully. Just because, okay, from the class area, let's select the main is there in the class area. Okay, what we are doing is from main, what we are doing, we are calling an object. Okay, sorry, we are creating an object. And from main we are creating an object, and through the object only we are making use of calculate interest. So, through the object as a mediator. Having the object as a mediator, we are calling the calculate interest. We can do this. Okay? We can create an object, and by using object as a mediator, we can make use of non-static methods inside static methods. So, now if I try to execute, this will be executed. This will be compiled as well as executed very successfully. This is compiled, plus executed. Now, if the interviewer asks you like, can I make use of non-static methods inside the static methods? Can I make use of non-static methods inside the static methods? Yes or no? Yes. Did I ask like, can I make use of non-static methods inside static methods directly? No, it's not. It was not my question. So, first understand the question. Okay. If the interview asks you like, can I make use of non-static methods inside static methods? Yes, it's possible by creating the object to that class. By creating the object to that class. Okay. So, can I make use of non-static methods of one class in another class? Means yes. Even this is possible. Create an object to another class and call the test method. Okay, just create object to another class and call the test method. Even this is possible. We are making use of non-static method of one class in another class. Okay. Now let me try to compile and even execute this. Where it is calling? It's calling the test method. It's calling the test method of another class. Okay. So we can make use of non-static methods. Okay, through the object by making use of object as a reference. Okay. Now, what is a new space class name followed by parenthesis will do? Means, okay, the first thing the new space this class name followed by parenthesis will do is this. It will create an object in the code. We go for new space class name followed by parenthesis. First, we create an object in the code. Okay. In the object, it will have its own set of non-static attributes and non-static methods. Let's consider like we have a class person. Let me name the class as person, and we have the ID of the person. It's a simple thing. Okay. Now, even we have name of the person. Okay, it's a very simple object. Now we have given a test. Now what is the domain? Let me try to create an object to person class. Previously it was another class. Now let me try to create an object to person class. Okay. Now what I am doing is I am creating an object to person class. The sixth statement what I am doing, I am trying to create an object to person class. And using the object as a reference, I am calling the test method which is non-static. Now, what I am doing is, first I am creating the object. If you want to create an object, what I need to do is, I have to go for a new followed by a class name, followed by parenthesis. Okay. Now, what is new followed by class name followed by parenthesis? Now, what this will do means, this will create an object. The object will be created in the heap. Once after the object is created, next step is, it will load all the non-static attributes into the object. Okay? What are the non-static attributes present in the person class? What is the ID and name. After loading all the non-static attributes, okay, the default values will be assigned. 0, none. Default values will be assigned. Okay. After assigning the default values, then references to all non-static methods will be created. How many non-static methods are there? How many non-static methods are there in the person class? Only one. Okay. The method is test, and the reference to test method will be created. A reference to test method will be created with where test is stored in the method element. Okay. Now this is the object that we have. Okay. And after creating the object, okay. Now a temporary reference will be created to the object. Okay. After creating the object, a temporary reference will be created for that object, and the temporary reference will be available only to that statement. Let's consider where I am creating the object in the 7th statement. Okay, and the temporary reference created for that object will be available only in the 7th statement. In the 8th statement, that object reference will not be available. Okay. It will create a temporary reference to that object, and temporary reference will be available only to that statement. Okay? And after creating temporary reference, what it will do means it will call this block. Now, did I define a block like this? See, this is an executable block, and did I define a block like this? In the person class, do I have a block like this? In the person class, do we have a block like this? Test? Yes, it is there. It is a method. Now, do we have any block like this? Do we have any executable block like this in the person class? No. Okay. See, the class name followed by parenthesis is called as a constructor. The class name followed by parenthesis is called as a constructor. This structure, the class name followed by parenthesis, is called as constructor. And even constructor is also an executable block in the class. Even the constructor is also an executable block in the class. Okay. Now, did we define this constructor in the class person? Did we define the constructor in the class person? Yes or no? Did we define the constructor in the class person? That's what my question. Whether the answer is yes or no. Okay. Did we define this test method? Did we define this test method in the class person? Yes. If it is yes, we have the class method in the test method in the class person. In the same way, what I am asking is, do we have did we define this person constructor in our class? No. Okay. In that case, what happens is, it should give a compile-them error, right? See, if we are using some block, if we are using some executable block, and that executable block is not defined, definitely it is a compile-them error. Understood? If we are making use of some executable block, and if that executable block is not defined in that class, then definitely it will be a compile-them error. Now, did we define person constructor in that class? In the person class? Yes or no? No. We did not define the person constructor in the person class. Then it should be a compile-them error actually. If we are using some block and the block, the definition to that block doesn't exist. If we are using some executable block, but the definition to that executable block doesn't exist in the class, definitely it will be a compile-them error. Now, let us see, it will give a compile-them error or not. Is it giving a compile-them error? No. But did I define the person constructor in the class? Yes or no? No. Okay. If the class doesn't contain at least one constructor, if the class doesn't contain at least one constructor, then the compiler will take the responsibility of putting a constructor in the class. Okay. If there is no at least one constructor in the class, if at least one constructor is not there in the class, if at least one constructor is not there in the class, then the compiler will create a constructor in the class. And the constructor which is created by the compiler, is called default constructor. The constructor which is created by the compiler is called default constructor. The constructor which is created by the compiler is called default constructor. And the default constructor will be created by the compiler if the compiler doesn't find at least one constructor for the class. Default constructor will be created by the compiler if the compiler doesn't find at least one constructor for the class. The default constructor will be created by the compiler when the compiler doesn't find at least one constructor for the class. Now, for person class, will the compiler take the responsibility of creation of default constructor? Yes. For member demo class? For member demo class, will the compiler take the responsibility of creating a default constructor? Yes or no? Yes. Definitely yes, just because we don't have any constructor defined in the member demo class. For each and every class, the compiler will create a constructor if not even one constructor exists. That's the clause. For each and every class, the compiler will create a constructor if at least one constructor is not found in the class. Now let me remove all these methods. Now we don't have a constructor in the class, so the compiler will create a constructor. Now how we can define a constructor means just the constructor name will be the class name. Okay. Now, will the compiler take the responsibility of creating the constructor for person class? No. But for member demo class, still the compiler will take the responsibility just because we did not define any constructor for member demo class. Now, for this statement, the first thing that is done for this statement is the object is created in the heap. That's the first thing. For this statement, the first thing that is done is the object will be created in the heap. After creating the object in the heap, the second step is what it will do is just it will load all the non-static attributes. Into the heap. ID, name, and then it will assign the default values 0, none. Once the default values are assigned, the next step is it will create references to all non-static methods. We create references to all non-static methods. So a reference will be created to test method, which points to the method area of that class. Okay. Now the object is ready. Once the object is ready, the next step is a temporary reference will be created for that object. Now, from where we have created the object? From where we have created the object? From where we have changed the object? 7th line. So where it will be? Where the 7th line is? In the main method. So in the main method, while executing the first line, it will execute the method. While executing the second line, what it will do? It will create a temporary reference in the stack. Temporary reference will not be created in the heap. Temporary references will be created in the stack. So it will create a temporary reference to that object. After creating a reference to the non-static methods from the object, okay, then the next step is to the object itself a temporary reference will be created from the stack, and the temporary reference will be available only to that statement. If it goes to the next statement, the temporary reference will be expired. If you go to the next statement, the temporary reference will be expired. So the temporary reference will be available in the stack, and that temporary reference, okay, will be referring the object. Now, the next step is, after creating the temporary reference, the next step is the constructor of that particular object will be executed. Now, which constructor we are using to create the object? We are using the person constructor to create the object. So, the person constructor will be executed. After all these things are done, after creating the temporary reference, the next step is execution of the constructor. So, for each and every object creation, constructor will be executed. Whether the constructor is created by ourselves or the constructor is created by the compiler. Okay? Whether the constructor is created by us in the application, or it might be the compiler, it might be the constructor which is created by the compiler. The constructor will be executed while creating the object. Okay? While creating the object, the compiler, while creating the object, the constructor will be executed. First, the object is created, then the non-static attributes will be loaded, default values are assigned, references to methods are created, which points to the method area, and a temporary reference to the whole object will be created in the heap. Temporary reference to the whole object will be created in the stack, and the next step is execution of the constructor. Okay, and once the constructor is executed, and then it will switch to the members. Now, after the highlighted portion, okay, contains the temporary reference of that object. The highlighted portion contains the temporary reference of that object. Okay, the highlighted portion contains the temporary reference of the object. So, using the temporary reference of the object, what we are doing? We are executing the method. Now, what the runtime environment will check is, do we have the reference of the test method? Do we have the reference of the test method inside this object? Yes or no? Yes. So, if you execute, if you bring the reference of the method, if you bring the reference of the test method to the stack, and you will execute the test method. So, by using object as a bridge, we are executing the methods. Okay? Let's consider like there is a test method in member demo. There is a test method in members demo. There is the same test method in member demo also. Now, which test method is executed? The person class test method is executed, or member demo class test method is executed? Definitely the person class test method is executed now. Just because we are executing the test method through the reference of the person class. So, if I compile and execute this, see the test method of the person class is executed. Before executing the test method, first the constructor is executed. Okay? For execution of a test method, it will consider the object as a reference. Now, which method is executed? Which test method is executed? Persons or member demo class? Definitely the member demo class method is executed. So the test member demo is executed. Now here the execution of the code, okay, depends upon the object that we create. Okay, the execution of test method depends upon the object that we create. If you create an object for the member demo, then the member demo class test method is executed. If you create an object for person, then the person class test method is executed. That means the execution of code depends upon object. That's why this programming language is called as object-oriented programming language. Okay, but in primitive languages like C, the execution of code doesn't depend upon the data. Okay, the data depends upon the code, but the execution of code doesn't depend upon the data in programming languages like C. So the execution of code is independent of data in programming languages like C. Those languages are called as structured programming languages. Just because the structure here is not the structures in C. The structure in structured programming language is the code. Okay? C language is called as structured programming language just because the structure, the code is the supreme there. Okay? The execution of code doesn't depend upon the data. So the code is supreme there, and the execution of code doesn't depend upon the data. So those programming languages like C are called as structured programming languages. But here Java and C++, if you want to make a use of a method, we can make use of that method only through the object reference. So here the programming language is said to be an object-oriented programming language or object-centric programming language. Just because if you want to execute the code, we should execute through the object. Okay? So these programming languages like Java, C++, PHP, .NET, all these languages are called object-oriented programming languages. Just because only through the object we can execute the code. Okay? Only through the object as a reference we can execute the code. So these are called as object-oriented programming languages. So execution of the code will be in our hand. If we want to execute member demo class test method, we can execute that. If we want to execute person class test method, we can execute the person class test method. So execution of code will depend upon the data. So this programming language is called as object-oriented programming language. Understood the difference between structured programming languages and object-oriented programming languages? Understood? The structured programming language, we cannot restrict. We cannot restrict which method should be executed. Only the specific method is executed. But here, we can restrict which class method should be executed through the object. So the execution of code can be restricted through data. So these programming languages are called as object-oriented programming languages. Understood? Okay. And new space, some constructor will create an object. New space, a constructor will create an object to the class. Using the temporary reference of that object created, this holds the temporary reference to that object. Through the temporary reference, we are making a call to the test method. Okay? And this will make a call to the constructor. But the constructor doesn't exist in the class. Even the constructor doesn't exist in the class, the compiler will create a constructor. So the compiler created constructor is called as a default constructor. And the default constructor will be executed after doing all the stuff. After doing all the stuff, finally the constructors will be executed, and the default constructor will be executed in this case for member demo class. Understood? Okay. Practice all these things. I have some work to go, so just we'll discuss the remaining things in the next class. Okay.
Where does the constructor define the memory?
That's a different concept. For each and every constructor, the compiler will create a method. In memory constructor, there is execute only methods will execute.